functions, domain, range. Then we will also do some questions about quadratic, log, inequality. Now, basically, we are going for the IIT part. So, IIT, it never happens that a question will be asked only from the quadratic chapter. So whatever question is asked involves concepts related to multiple chapters. Okay. So we will, whenever question is given, lot many means now for IIT sessions there will be no such thing as which particular topic you are teaching. So the questions that we will be doing it will involve all the topics combined. So let's start with the basics. Quadratic only, you know how to solve a quadratic equation. So first, the set of values of x for which x square minus 3x minus 5 is greater than 0 is some interval. It will be some values of x will satisfy these values, these conditions, some will not. Tell me what it is. If the answer is in the form of means the end points of the interval, if the end points of the interval are in the form of a fraction or surds, let it be in the form of fraction. No need to convert it into decimal or something. If it is in the form of Dhananjay, you have made the mistake in the interval, means you obtain the roots correctly. 3 minus root 29 is the lesser number, Dhananjay. So, okay, see the set of values of this equation. Now, x square minus 3x minus 5. If you see x square minus 3x minus 5, if we just analyze this function, I know that the graph of this function is a U shape, upward facing U. Since a is equal to 1, a is equals to 1, which is greater than 0. Now you are telling sir this the upward facing U should be greater than 0. For which values of x it is greater than 0? Now it may happen that the graph is completely upwards, or it is intersecting the point, the x-axis at one point, or it is intersecting the graph at proper 2 points. I don't know which. Means I can check that in this case, since A, B, C, all the three are known. So if the graph is, let's say this, if let's say the case it happens that the graph is of case 1. So for f of x to be greater than 0, what is my required interval? So the required interval is all the values of x. All the values of x, the graph is always positive. If the graph is of case 2, so what is the required interval? So the required interval graph of x should be greater than 0. So greater than 0 means all the points to the left, all the points to the right. So that single point we are not taking. Which single point? So that single point x equal to minus b by 2a. That single point we are only avoiding because at that point the graph becomes equal to 0. Had I given you x square minus 3x minus 5 greater than or equal to 0, in that case also the all the real values of x would have been the case. Now in the third case graph, the possibility of third case, if that is the graph situation occurs, then the interval would be, sir, all the points to the left of the lesser root and all the points to the right of the greater root. These 2 points are alpha and beta. So all the points to the left lesser than alpha and all the points greater than alpha, because for x's, for the values of x lying between alpha and beta, the graph is negative, so that is not the answer, and for alpha and beta the graph is 0. So now check which of the following is the case. Okay, and if suppose, and in case the graph is, let's say, inverted u, some quadratic is given and graph is inverted in, and you verified that the graph has 2 distinct roots, suppose that would have been the case, then in that case the answer would have been this value. So now you know how to approach the problem. So here you can see that this graph b square minus 4ac, b square minus 4ac is equals to minus b, that is 3 minus 3 square minus 4 times a into minus 5. So this comes out to be 5 4s are 20 and 29, which is greater than 0. So the graph has 2 distinct roots. And what are the 2 distinct roots? Alpha and beta is equals to minus b. Minus b is 3 plus minus in under root b square minus 4ac, that is 29 upon 2a. So that is 200. So the lesser root is 3 negative 29 under root upon 2, and 3, because 3 plus root 29 is obviously greater than 3 minus root 29, and when you are dividing it by 2, so that will be the case. You have to locate the roots exactly, and now the answer will be this interval. So x belongs to minus infinity to 3 minus root 29 upon 2 open, because I want strictly greater than 0, union 3 plus root 29 upon 2 up to infinity. This will be the answer. Okay, clear? Pujita understood what is that minus 3 by 2 has no role over here.
Yes, sir. Yes, sir.
Okay. Now similar lines, on the similar line, next question is there. Now I will just change the middle value. Yes. I will make it little more complicated. Set of values of x for which x square minus modulus of plus x is greater than 0 is unless you can form the quadratic, you can form a particular function. Till that point, you cannot solve it. No, Pujita, wrong. Still wrong, Pujita. Okay. C. The first modulus of x plus 2, it will be x plus 2 if x. Now, what is the center point of this mod function? In this case, the center point of this mod function is negative 2. Can you realize this? So if x is to the right of this mod, means modulus of x plus 2 is right as it is. If it is to the right, means x is greater than negative, or let's say for that matter equal to also. We write as it is. And if x is less than negative 2, we write minus of x plus 2. Yes, correct, Dhananjay. First step, is it clear, Harini, Pujita, what I have written up till now, the modulus function, that's it. Mod
Yes, sir.
y, okay, mod y, we write is equals to y as it is. Mod के अंदर जो कुछ भी है, inside the modulus, whatever expression it is there, we write as it is. If that expression is greater than 0, and if that expression is negative, we take minus of that, so that negative of negative becomes positive. So that's what I did. So now the function case 1, if x greater than 0, if x greater than or equal to negative 2, then our function becomes x square minus, what is modulus of x plus 2? So modulus of x plus 2 is x plus 2 only, and plus x should be greater than 0. So on simplification, this gives x square minus 2 minus x plus x gets cancelled out. This should be greater than 0. So when is x square minus 2 greater than 0? Now this is a quadratic similar to the previous questions. Case 3 graph will apply. Then the question that we are solving. Case 3 graph will apply. X square minus 2 should be greater than 0. So what are the roots in that case? In this case, roots find the roots, it's very easy. X minus root 2, x plus root 2 should be greater than 0. Either go by the quadratic approach or go by the wavy curve method in the linear inequalities. While studying inequalities, I told you the wavy curve method. One root is negative of root 2, another root is positive root 2, and these points are the hollow points since we want strictly greater than 0. And what is how the wave will go? So the wave will go in this format. The wave changes direction at these critical points if the exponent, if the power of that factor is an odd number, odd integer. If the exponent, if here would have been, let's say, let raised to 4, then the sign, the wave would not have changed the direction at minus root 2. Just a revision. Okay. So this is the first case. So what is the first case answer? The first case answer, I want greater than 0. So the greater than 0 answer is these two intervals. So x should be either greater than root 2 or x should be less than negative of root 2 or it should be greater than root 2. But hold this thing, it is true, it happens only if the original condition is satisfied. What is our original condition? Sir, x should be greater than negative 2. So now where is the position of negative 2? You can see that the position of negative 2 in this case, negative 2, it will be here. Magnitude wise, we will have to see. Negative of root 2 is negative 1 point something, negative 2 will be here. Now this whole thing will be true only if x is greater than or equal to negative 2. So this part I will have to delete. So the answer, combined answer in case 1. Case 1, combined answer is x belongs to, sir, minus 2 equal, okay, greater than or equal to minus 2 and up to negative root 2 and negative root 2 strictly less than, union root 2 strictly greater than up to infinity. This is the first case scenario. Okay, and now case 2. Case 2, if x is less than, if x is less than minus 2. If x is less than minus 2, then the function becomes x square minus modulus of x plus 2. What is modulus of x plus 2, sir? X plus 2 with a complete negative sign. So this becomes plus. And in the end, plus x is already there. So this is the function. So the function becomes x square plus 2x plus 2 is greater than 0. So if you solve this equation, x square plus 2x plus 2, how the graph looks like? So I will check for the value of b square minus 4 is a is greater than 1. Here the value of a is equals to 1, which is, so it is an upward facing u. Second, b square minus 4ac, b square minus 4ac, it turns out to be equal to 2 square 4 minus 4 multiplied by ac. So it turns out to be negative. Okay. So b square minus 4ac is less than 0. So can you see that the graph is completely above the x-axis? No real roots. No real roots. It is completely above the x-axis. Can you see this thing? Case 1, case 2, case 3. The three graphs which
yes, sir. Yes, sir.
Okay. The three graphs which we have. So it does not intersect the x-axis at any point. No real roots. It is completely above the x-axis. And therefore x, now we want that this expression should be greater than 0. So you can see that, sir, all the values of x satisfies. So x belongs to real numbers. X belongs to real numbers, but this is true only if the original condition is satisfied. So the original condition should be satisfied. So x equal to minus 2 wherever that point is. I don't know where that point is, minus 2. It should be strictly less than. So the combined answer will be, combined answer of these two will be x should be less than minus. So case 1 and case 2. If it is case 1, the answer is this. And if x is less than minus 2, in that case, the answer is this. So the final answer, x can be greater than minus 2 also, negative less than minus 2 also. So the final answer will be x belongs to, you will have to combine this green, this answer and this answer. You'll have to take their unions, everything. Okay, means depending, sometimes you have to take union, sometimes you have to take intersection. Here it is if x greater than negative 2 or less than negative. So it is a union in this case. So the answer will be, sir, negative 2 greater than, we have already decided, less than negative 2, each and everything. So you can say that it is minus infinity to negative 2 here. Minus 2 is included in the first case, so up till negative root 2. Open at negative union root 2 to infinity. This will be my final answer. Okay. Then
Yes,
this will be the
sir.
solution. I hope you know how to solve this question. 2x plus 3 upon, let's say, x minus 5 greater than 0. This you will solve by the wavy curve method. Now this part I am not explaining how to solve this thing. Okay, by the wavy curve method that can be solved. But if I tell you to solve this greater than 1, now how to do? For that matter, greater than 2 will also suffice, greater than 3 something, anything. So the problem here is, if you think you will multiply by x minus 5, that cannot be done. Means it can be done, but that will be a problem. If you think so, multiply both the sides by x minus 5 and you will say that 2x plus 3, and left hand side is x. If I multiply LHS by x minus 5, denominator gets cancelled. If I multiply RHS by x minus 5, it becomes x minus 5. So now the problem arises, what should write? Whether should I maintain the inequality as it is or should I reverse the inequality, because x minus 5 can be positive, it can be negative. Yes or no? So that way you cannot do, because multiplying by positive number inequality is maintained, multiplying by negative number inequality is reversed. So now you may think that, sir, we will consider again two cases. Case 1, x minus 5 positive, that is x greater than 5. Case 1, x greater than 5. Case 2, x less than 5. Again, that is it. In this example, okay, it may work. It means it will work. But again, that is not that a good approach, because suppose if I would have given you x minus 5 into x minus 2 into x minus 3, let's say, then you will have to consider many intervals, 2, 3, 5. So better way, what is simply, so better way is, means this is one approach, okay, the one that I have told you, this is one approach. Another approach is, two x plus 3 upon x minus 5. So if I simply subtract 1, if I bring 1 to the LHS, it will become 0. There definitely the inequality will be maintained. And now 2x plus 3 subtraction, and now I'm just simplifying it, upon x minus 5. So this becomes minus of x minus 5. So minus x plus 5 greater than 0. Now simplification gives x plus 8 upon x minus 5 greater than 0. How to do this? The wavy curve method. One root is 5, which should be a hollow point, since it is in the denominator cannot be negative. One root is negative 8. That equality is allowed, but here we want strictly greater than 0, so that equality also will have to rule out. So then the wave becomes, the exponent at the factor, corresponding factor x minus 5 is odd number, it will change its direction. The exponent at the corresponding factor of x plus 8, that is the exponent here is an odd number, so it will change its direction. So we want greater than 0, so the answer will be x belongs to minus infinity to minus infinity to minus 8 union 5 to infinity. This part is of inequality, that it's just a revision question. Okay, this part is clear. Now I want you to solve this question. Log to the base 3 of x square minus 4x modulus plus 3 upon x square plus modulus of x minus 5 greater than or equal to 0. Find values of x satisfying this inequality. Here you will require your knowledge of inequalities, logarithms, modulus function, quadratic function. Log is a whole thing, okay? I have not written the bracket because I wrote systematically. So it was self-explanatory. That's why I did not use the bracket. Should I show you the page of logarithmic inequalities, or if you have it with you? So 4 minutes time. Okay, see. First, log of some expression to the base 3 greater than or equal to 0. I hope you remember this inequality from the log chapter. We take log of y to the base 3 greater than or equal to this. So that expression as it, whatever it is there, modulus of x square minus 4x plus 3 upon x square plus modulus of x minus 5. This should be now base here. The base is greater than 1. You see the for the base of the logarithm, we see that if the base is between 0 and 1, and if it is greater than 1, the two intervals between 0 and 1, which reverse the inequality sign. Greater than 1, we maintain the inequality sign, and here it becomes 3 raised to 0. 3 raised to 0 is 1. Up till here, I hope there is no doubt. At any stage, if any, it means while explaining it, at any step, if you have doubt, unmute and write, ask me, right? Ask me at that step itself. Now, it becomes question, the question arises similar to previous case. Now, if you go by method, this method 2, let's say I will bring method 1. What was the problem? So method 1, the problem was we have to consider the cases. The denominator is a variable. Now variable, it may be sometimes positive, sometimes negative. So while multiplying, we have to consider the cases. That's why we went for method 2, and method 2 subtraction was, so that way we did. Now here, if you think, so I will bring subtraction here. And then if you think, sir, subtraction, in the numerator, it becomes x square plus modulus of x minus 5. So in the numerator part, you have modulus of x square minus 4x, which is, again, you will have to consider cases. Which cases? 0 and 4. 0 and 4 means what? 0, 4. The graph of this mod. The graph of this mod is something like this. So to continue, whether to consider x square minus 4x or negative of x square minus 4x, you will have two cases. Which two cases? Case 1, x is lesser than 0 or greater than 4, and case 2, x is between 0 and 4. And then for this x square and x minus 5, this mod also, combiningly, we have, with that you will have x, the one root about 5, one root about 0. It will be very, very complicated. So that approach is not feasible. So can we solve it some another way? Miss, if there wouldn't have been any other way, that is the only approach. But here there is one smart observation. What smart observation you have? That, sir, if I observe my denominator x square plus modulus of x minus 5, that term is always positive. It can never be negative. You just observe this x square, the denominator x square modulus plus mod of x minus 5. Sir, x square is obviously greater than or equal to 0, and modulus is also greater than or equal to 0. So the addition is always greater than or equal to 0. This addition is always greater than or equal to 0. So can it be equal to 0? See that it can never be 0, because the addition, combined addition, denominator, because two positives addition will be 0 only if both of them are simultaneously 0, and simultaneously they cannot be 0. First term is 0 at x equal to 0, and the second one at x equal to 5. So equality at 0 is also, we can rule out. So since denominator, we are damn sure it is positive, we can directly multiply. We are actually multiplying the LHS and the RHS by a function, but that function is a very nice function since it is always positive. So we can be confident that inequality won't be disturbed. It will be as it is. And now, after this, you have to consider what the critical points for this x square minus 4x. The critical point is 0 and 4. And for that x minus 5, that critical point is 5. Okay. So what happens now? We will divide it into intervals. For less than 0 and now x greater than 5 and less than 5, correct? For with respect to, if I observe with respect to this point, x minus 5. with respect to, I will require some colors. With respect to x square minus 4x, what are my intervals? This is my interval where everything is positive. And the other interval is between 0 and 4. And with respect to x minus 5, I have another intervals. Now you'll have to picturize it, means you have to something, what do I say? You have to some manage, you have to this manage yourself, some common intervals. Case 1, sir, x greater than or equal to 5. Greater than or equal to 5, so the left interval, the function will become x square minus 4x. Modulus will be, sir, in the blue part. Addition 3, greater than or equal to x square plus x minus 5. This step, any doubt? Please ask. So x square minus 4x graph.
So can you repeat it again, sir?
Okay. X square minus 4x. Till this step, is it clear?
Yes, sir.
Okay. Now after that, x square minus 4x, the interval of, if I just consider x square minus 4x modulus, that graph is this way, 0 and 4. So less than 0 or greater than 4, the function will be x square minus 4x. And between 0 and 4, the function will be negative of x square minus 4x. This part we did earlier. I think Afrin asked this question, right? Afrin?
Yes, sir.
Okay. So this should be clear to you, Afrin. This part we have done in the first 3 questions.
Yes, sir.
I think
Yes, sir.
you joined it. So that only I did, since I'm taking x greater than or equal to 5. That it is already in the blue interval. The blue interval, so x square minus 4x will be the mod value plus 3 greater than or equal to x square plus x minus 5. This will get cancelled. Now it's a simple inequality. Minus 5x. Minus 5x greater than or equal to negative 8. I will divide by minus 5. So when I divide by minus 5, so it becomes 8 upon 5. I will reverse the inequality. So it should have written actually x is less than or equal to 1.6. So this should be the answer if the original condition is x greater than 5. So these two combinedly, combining these two, if x greater than 5, the final condition should be x greater than or equal to minus 6. So x equal to 5. Okay. Case 2, x less than 5. So now if x is less than 5, if x is less than 5, okay, if x is less than 5, so LHS I don't have to worry about now. Sorry, RHS. The RHS is now definitely x square plus what is modulus of x minus 5? Modulus of x minus 5 is minus of x minus 5. Now my RHS is fixed. Now I only have to worry about my LHS. So my LHS in that between 4 and 5, or for the blue part, blue interval intersection, blue interval and less than 5. What is my case 2? Are you getting it? Means I'm shortening it. You can either take 4 cases: greater than 5, between 4 and 5, between 0 and 4, less than 0. 4 cases: case 1, case 2, case 3, case 4. Case A, case B, case C, case D. But I'm trying to tell you how to think in a shortcut manner. Means with practice, this you should be able to think in that way. Less than 5 and in the blue interval, less than 5 and in the blue interval. So my RHS is sorted out. What is my LHS? In the blue interval and less than 5. Blue interval and less than 5. So my modulus of x square minus 4x. Modulus of x square minus 4x is x square minus 4x only. Plus 3 will remain as it is. So this is my answer. This is my function. X square minus 4x plus 3 greater than or equal to x square minus x plus 5. Solve it. It gives you minus 3x greater than or equal to 2. So x dividing by minus 3, it becomes minus 2 by 3, and the inequality will be reversed. Now, combine the answer. The combination of these answers, let's see. This is 0, here is 4, here is 5. And where is minus 2 by 3? Minus 2 by 3, it comes out to be over here. What is my original interval? My original interval is a blue interval and less than 5. So my either I can be here or I can be here. And I want it should be less than negative 2 upon 3. So negative 2 upon 3. So I will delete it. I will delete it. Minus 2 by 3 means it is satisfying my original condition. This original condition is being satisfied. So combination, you will have to take intersection of these 2 points, intersection of these 2 intervals. So x, everything less than minus 2 by 3. Sorry, less than or equal to. This is my one answer. Okay. And case 3, or for that matter, that means take this was case 2.1 because we were doing less than 5. Okay. And case 2.2, less than 5 only we were dealing. But now in this interval, what should I write? The purple interval. Purple and less than 5. So that for that I can directly write x belongs to, that is x between 0 and 4. That I can directly write here now because less than 5 and the purple interval, so between 0 and 4. Okay. So for that matter, the LHS is, so modulus of x square minus 4x. Modulus of x square minus 4x in that case will be negative. So negative x square plus 4x plus 3 is there, and I want this greater than or equal to x square. Modulus of x minus 5 will be minus of x minus 5. So okay, so I will just do the corrections here only. Minus of x minus 5 will be minus x plus 5. Now do the necessary calculations. So here negative 2x square plus 5x minus 2 greater than or equal to 0. Now I personally find a to be negative, little bit discomforting. So ax square, if it is negative, it is my personal what's the discomfort. So I will just make it 2x square minus 5x plus 2 less than or equal to 0. I can see that the factors of this 2x, x, 2, 1 minus minus. So the factorization is 2x minus 1, x minus 2 less than or equal to 0. So 2x minus 1, x minus 2 less than or equal to 0. So the graph is something like this. One root is 1 by 2, another root is 2. I want less than or equal to 0. So this is my required interval. So x should be between 1 by 2 to 2, and both the points will be included. But this condition is when original condition between 0 and 4. So what are the relative positions of 0 and 4? Yes, so 0 is here, 4 is here. So yes, they satisfy our original condition. So the final answer of these two is intersection. Intersection of these two will be this one. So combining now all the answers, all the possibilities and all the answers that we got. Case 1 we got 5. Case 2 we got less than or equal to 2 by 3, and then case 3 this. So finally the answer will be x less than or equal to negative 2 by 3 union half to 2. Okay, clear everyone? This is the explanation. Shall I move on to the next question? Dhananjay, Harini, Pujita, Afrin, Afrin.
Yes, sir. Yes, sir.
No, getting no.
Yes,
You
sir.
you joined
Sir,
it with,
actually, I had to tell that from 1 week, like past 1 week, I didn't attend any of the classes because I was out of station and I was not able to attend any of my school classes also because I didn't have proper net. If I had also, I couldn't because I was in a family trip, sir. So,
okay.
what shall I do for that, sir, to recover all that? Shall I see
Uh,
the recordings?
yes, yes. Go through the recordings.
Okay, sir.
Let's go to some questions. Yeah, one question. This is comparatively very easy question. Now, this you should be able to do. If alpha and beta, where alpha is less than beta, it
There
is
one
given to you.
scroll the answer.
More.
Done, sir. Done, sir.
If alpha less than beta, are roots of x square plus bx plus c equal to 0, where this condition is given to you, then Okay, Pujita, how did you arrive at the answer? Just 1 second, okay, please, 1 second.
Sir, I guessed it, sir.
Okay, Pujita, tell me, how did you conclude that answer?
Sir, I guessed it, sir.
Every time you do the guesswork, it's not the proper approach. See, what is asked in the question, it's just he's asking you the signatures, the sign of a alpha beta, whether they are positive or negative. We should try to interpret the question correctly. He's not asking the actual values. He's just the options. If you observe on the basis of the options, he's just asking which are positive, which are negative. And so, what about that mod alpha, mod beta? Something mod alpha is there in the options. Whether numerically beta is greater or numerically beta is smaller than alpha, something like that. See, now here we know that alpha and beta, he has given that alpha is less than beta, and just C is negative and B is positive. That's the only thing which he has given. So now what do we know? So we know that, sir, alpha addition beta is equals to minus B by A. Minus B by A is what, sir? Minus B only in this case. And alpha beta is C upon A. C upon A, in this case it is what? In this case it is C only. Correct? Now, so can you see that alpha beta is equal to a negative value from the information that he has given, because C is less than 0, greater less than B. So alpha beta is negative. And what I have told you, that alpha beta, that means the product of the roots is negative. So in complex number, I have already told you that if at all the root of a means the quadratic equation does not have real roots, if at all the roots are complex, then the complex roots always occur in conjugate pairs. This you already know. So the complex roots always occur if they are occurring in conjugate pairs, and means x square plus bx plus c if alpha and beta are complex number. So can you see that p plus iq and p minus iq, p plus iq and p minus iq will be the roots, means with quadratic equation with real coefficients. The two roots will be conjugates, and multiplication of conjugates, complex numbers conjugates, it is always and always positive. P square plus q square, which is always greater than 0, not even equal to 0, because conjugates for complex we are taking. Okay, this you can see, multiplication of conjugates is always greater than 0. And here, so product of the roots is negative. So one remark you can write. If product of roots of a quadratic equation is negative, then we can definitely say, then the roots are definitely real numbers. And in definitely real number, why? Because if they are complex, then they have to occur in conjugate pairs, and conjugate pairs, the product is always positive. And now what bracket I have given, that product of the roots of a quadratic equation with real coefficients. When I, this whole property that roots occur in conjugate pairs, this is true only if the coefficients with real coefficients. If A, B, C, the coefficients of the quadratic equation is real, then we can say that property, that roots occur in conjugate pairs. Okay, it's definitely real numbers. And also, now product of the roots is negative, means product of two real numbers is negative. So also, when it is possible that one root is negative and one root is positive, when one is negative and other is positive, one is negative and other is positive. This remark you can write. So now here we have, sir, alpha is one root is negative, one root is positive. Since he has given that alpha is less than beta, so now I can definitely conclude that, sir, since alpha beta is equals to negative and alpha less than beta, we have that, sir, alpha is less than 0 and beta is greater than 0. One is negative and one is positive. Now, what about that magnitude alpha numerically? Alpha plus beta is equals to minus b. Alpha plus beta is equals to minus b if I have. Alpha plus beta is equals to minus b. Since b is positive, he has given me. So alpha plus beta is equals to a negative number. Minus of a positive, so alpha plus beta is negative. So now you are having one negative integer and one positive integer. Total they are making negative. So can you say that the negative numerical value, positive or negative, तुम add कैसे करते हो? How do you add a positive integer and a negative integer? You actually subtract them and you give the signature of the integer which is numerically greater. So here numerically alpha is greater. Numerically alpha is greater means what? Magnitude of alpha is greater and then magnitude of beta, and magnitude of beta is beta only because beta is positive. So can I say alpha less than 0 less than beta, and this is less than magnitude of alpha? Okay, this will be my answer. So correct option B. Got it, everyone?
Yes, sir.
Okay. Find domain and range of f of x is equals to I've told you the language of this function. If he is asking you the find the domain of a function, the language of the question is what? Find the domain of a function. So means the person asking you, it's a standard language that I want this f of x to be a function. I want this mapping, this formula to be a function. In order to make it a function, do whatever you want to do. From the first set, that is R to R, remove all the problematic points. At least answer the domain. The range part I will explain you. So I don't think you will be able to solve the range part here. Just tell me the domain. Find the domain and range of real valued function f of x equal to this. Just answer the domain. Come on, students, answer something. Dhananjay getting? Dhananjay? What will be the domain? Dhananjay, what will be the domain? I cannot hear you. You are unmuted. See, domain is a, sir, actually the domain is the first set only. But why, why are you asking find the domain? I am asking you find the domain of the function because I'm asking you the domain of the function. Domain of the function we have seen. What is the meaning of language? Language मतलब किसी ने अगर ये पूछ लिया कि domain का मतलब क्या? So if it's find domain, there's language you have seen. Find the domain. So domain language part. See the language part we have seen. Find the domain of f of x. So the question is actually in order to make this mapping to be a function, just tell me what should be the domain. So remove all the problematic points from the first set. Remove the problematic points. Which are the problematic points? Either they are not forming any images or they are forming more than one image. Those are the problematic points that we will remove. So that thing, that is the language of the question. So here domain is equals to set the first set. What is my first set? Yes, the screen should be visible now. What is my first set? My first set is R, and out of this R, I will remove the set of problematic points. What are the set of problematic points? So this f of x equal to 2 minus x upon 3 minus x. For each and every x, it is defined except the point 3. Because if 3 it is there, then the denominator becomes 0. And if denominator becomes 0, then image of 3 is not possible. So domain is minus infinity to 3 and 3 to infinity, or you can just write R minus singleton set 3. Okay, it's one and the same thing. Now what about range? Range part, I will solve this question for you. 2 minus x upon 3 minus x. 2 minus x upon 3 minus x. This is my y. So if I want to solve this question, 2 minus x upon 3 minus x, just multiply it. This is my mapping. So 2 minus x is equals to 3y minus xy. So now 2 minus x equal to 3y minus xy. So bring, means my target is to bring x as a formula of y. Right now I am having y as a formula of x. I want to write x as a formula of some formula of y. So for that thing, I will write, I'm doing all this. So now 2 minus 3y. 2 minus 3y will be equals to x minus xy. So 2 minus 3y is equals to x. I will take comma, that is 1 minus y. So x is equals to 2 minus 3y upon 1 minus y. Is this okay? So now I got x as a formula of y. So can you see now, since 1 minus y is in the denominator, since 1 minus y is in the denominator, we can see that if y equal to 1, if y equal to 1, then x is not defined. X is not possible. X is not possible, or you can say that does not belongs to real number. So you can say that, so yes, y cannot be equal to 1. If y equal to 1, then x is not possible. So now for that matter, can you see that now y is not equal to 1? Therefore, y not equal to 1 for all x belonging to real numbers. What happened? Here what? Did any one of you do something?
No, sir.
Just 1 second. Let me check whether how is it happen? How did it happen that automatically it got deleted? Okay, again do it. 2 minus x upon 2 minus x is equals to y.
Sir, we can't see screen sharing.
I forgot to share the screen. Yes, now I have shared it. Is it visible now, the screen?
Yes, sir.
Okay. So now 2 minus 3y is equals to x minus xy, which is equals to x times 1 minus y. So x is equals to 2 minus 3y upon 1 minus y. So can you see now that y, if y cannot be equal to 1 for x belonging to real numbers? Because if y is equals to 1, then x is not possible. Are you getting it? So y was, what was our y? So this y was actually the value of 2 minus x upon 3 minus, the set of images. So y can be all real numbers except 1. So can I say that the range of f of x is equals to 2 minus x upon 3 minus x, which is my function, is all the set of real numbers except the value 1. Is it okay?
Yes, sir.
Okay. So second, domain and range of f of x is equals to 2x minus 5 upon 2x minus 3. What is happening here? The part that got deleted, it came again. Okay, forget that. Concentrate. Exactly like previous question, no changes. Is it over? Domain is equals to everything except 3/2. Okay. What is range? At 3/2, the denominator becomes 0, so that is not possible. That should not. Okay. For range, I will just do the same thing. 2x minus 5 upon 2x minus 3 is equals to y. My target is to bring x as a formula of y. 2xy minus 3y becomes 2x minus 2xy is equals to 5 minus 3y. So 2x common, 1 minus y is equals to 5 minus 3y. So x is equals to 5 minus 3y upon 2 times 1 minus y. So can you see that y can upon 2 times 1 minus y? So can you see that y cannot be equals to 1 for x belonging to real numbers? That is, range of f of x is equals to set of real numbers except the value 1. Is it clear? Dhananjay and Pujita?
Yes, sir.
Now, in this question, only the third part. Domain and range of f of x is equals to 1 upon minus x square
Sir, domain is 4/3.
4/3.
Sir, we have to solve the equation, sir.
Hmm.
Okay, sir.
Domain is what? Set of real numbers except the problematic points. domain part is easy. If you don't get the range part, it's okay. Domain is equals to what's a set of real numbers minus this function is from f is from defined from R to R, correct? So we have to remove the problematic points from this first set. So the first set, that is R, minus set of points belonging to that set such that which are problematic. So which are the problematic points? So if the denominator becomes 0, then that's a problem. Minus x square plus 3x plus 4 is equals to 0. All those x's for which the denominator becomes 0, I will have to remove it. So I think this is very easy to solve that. So this equation, if you solve, this equation is actually what? X square negative 3x negative 4 is equals to 0. So it is x minus 4 into x plus 1 is equals to 0. So x minus 4, x plus 1 is equals to 0. So that will be equal to x is equals to 4 or minus 1. So all the real numbers except these 2 points, minus 1 and 4. I am removing 2 points. Okay, I'm not removing an interval. You're getting it? From that real numbers, I'm just removing 2 single points. I'm removing minus 1 and 4. I'm not removing an interval minus 1 and 4. So this is my domain. Up till here, no doubt. Now, I think you can find the range. If I would have given you only negative x square plus 3x plus 4, forget about 1 upon. 1 upon that quadratic, forget it. If I would have given you the simple quadratic, can you find the range of this quadratic? Yes, sir. That part we have already done. Today also and in the previous classes also for quadratic. How to find the range? The range of a quadratic is, we know, sir, f of minus b by 2a. We check that part. In the previous class, let me see this part, this class. Find the range of this graph, find the range of this quadratic. These questions we have seen, no? Find the range of this quadratic. Tuesday's class. It was Tuesday's class. We have Monday. Okay. So now, if I do method 1, first is the method 1. Dhananjay, were you able to solve the range? Were you able to find the range of this f of x? Okay. Now see, method 1. So the denominator is negative x square plus 3x plus 4. Okay, consider it g of x. It is some function g of x. So can I find the range of this function? Yes, sir. I can find the range of this function. The range of this function is how? So it's an inverted u, downward facing parabola, downward facing u. Since a is equals to 1, the a is equals to negative 1, which is less than 0. So downward facing u. So now, so the minimum value is negative infinity. What is the maximum value? So the maximum value occurs at x equals to minus b by 2a. Minus b upon 2a. So which is what? Minus b upon 2a. So minus 3 upon minus 2a. Minus b by 2a. So 2a is 2 into minus 1. So the maximum value occurs at x equal to 3 by 2. So can you say that g of x maximum? G of x, the maximum value occurs at g of minus b upon 2a, which is nothing but g of 3 by 2. So you just have to substitute g max. G max is equals to what it will be? 3 by 2 complete square with a negative sign minus of x square plus 3 times x. What is 3 times x? 3 into 3 by 2 plus 4. So if you do this calculation, so this will be minus of 9 upon 4 plus 9 upon 2 plus 4. So double 18, so 18 minus 9 plus 18, it becomes 9 upon 4, and this 4 as it is. I'm just doing arithmetic, nothing new. This is 18 upon 4 minus 9 upon 4, so 9 upon 4. So the maximum value is 4 4s are 16, 16 plus 9 is 25 upon 4. This is G max. So do I have the range of G of X? Yes, sir. G of X range I have. G of X, that is the denominator. It takes values from everything from negative infinity up to 25 upon 4. Correct? This was 25 upon 4. Everything from negative infinity to 25 upon 4. But I'm not interested in G of X. I'm interested in F of X, which is 1 upon G of X. What about 1 upon G of X? So 1 upon G of X. Now this is inequalities related to reciprocals. Inequalities related to reciprocals. That part we have seen. Inequalities related to reciprocals. How that reciprocals behaves. Do you remember? I told you to revise that all things for today's class. So 1 upon G of X. Now G of X passes through the 0 interval. 0 point. 0 is a very dangerous point. For the reciprocal, it causes a lot of problems. So we divide it into minus infinity to 0. Two intervals we divide, minus infinity to 0 and 0 to 25 by 4. So 1 upon G of X. 1 upon G of X, how it will behave? So 1 upon G of X. 1 upon G of X. So here G of X maximum value is 25 by 4. So the minimum value will be reciprocal 4 upon 25. And so G of X minimum you can take as much, means in the positive, this interval I'm talking about. You can G of X, you can reduce it as much as you want, 0 0.01, 0 0.001. So 1 upon G of X, you can take as big as you want. And now 1 upon G of X will be, sir, it will be, you can magnitude wise, you can take as, you can magnitude wise as big as you want, that is negative infinity, magnitude wise as big. So 1 upon G of X magnitude wise as small. G of X magnitude wise as small as you want, 0. So 1 upon G of X magnitude wise as big as you want, but in negatives. So it will be negative infinity. So F of X, my F of X is less than 0, greater than negative infinity, between 4 upon 25 and infinity. So the range of F of X, range is equals to minus infinity to 0 union 4 upon 25 to infinity. Okay. Wait. One mistake I did. G of X can be equal to, here equality is allowed. So here it will be a closed interval, here it will be a closed interval, here it will be a closed interval, here it will be a closed interval. This will be the answer. Okay. Yes. One last thing I want to tell, this question only. This question. Pujita in the chat box said bye. Okay, just one last thing I want to tell you. Method 2. Method 1 means it was related to previous questions only. Method 2. Here we take 2x minus 5 upon 2x minus 3 equal to y. Just give me 2 minutes. Okay, I will wrap up in 2 minutes, not more than that. Here you were lucky that it was on a quadratic. Where is the question? Yeah. 1 upon a quadratic equation, or let's say constant upon a quadratic equation. But every time you won't be that lucky. So for example, if I give you this example, let's say 2x minus 3 for that matter upon minus x square plus 3x plus 4. This is some h of x. I told you to find the range. Then there you cannot say that's a quadratic. I have the denominator, I will find its range, and then I will find the range of the reciprocal. That will not work. So for that, you will require 2x. This is equals to, for that method, it will quickly tell you. Please bear with me for 2 minutes. F of x is equals to 1 upon minus x square plus 3x plus 4. I will take this to be equals to y. So just if I do 1 is equals to negative y times x square plus 3y times x plus 4y. So just bring everything to the RHS. So this becomes y into x square plus 3y into x plus 1 minus 4y is equals to 0. Okay. Now in this quadratic equation, now I want x. This is the quadratic equation. Can you see that this is a quadratic equation in x? This equation is a quadratic equation in x.
Yes, sir.
Quadratic equation in x. And I know that x belongs to real numbers. My domain set is x belongs to real numbers. So my image is what? B square minus 4ac should be. Not b square minus 4ac is not the image. My b square minus 4ac is definitely greater than or equal to 0. Do you realize this part?
Yes, sir.
Okay. So for that, b is what? 3y complete square minus 4 into what is a? A is y. What is c? C is 1 minus 4y greater than or equal to 0. So now we again get a quadratic in y. The simplification of this becomes 9y square minus 4y plus 16y square greater than or equal to 0. So this becomes 25y square minus 4y greater than or equal to 0. So it is y into 25y minus 4 greater than or equal to 0. One root is 0, another root is 25 upon 4. The graph becomes this way. I want this multiplication to be positive, so the interval is either this or this. Okay. And y cannot be equal to 0 because here the leading coefficient is yx square. So here the leading coefficient we have y not equal to 0. Okay. So y not equal to 0. So combining the two answers, I have minus infinity to 0 open union. Actually here the green, the part that we got here, 0 is included, but the original condition was y should not be zero. And 25 by 4 close to infinity, which is our answer. The same answer we got above also. Yes or no?
Yes, sir.
And finally, for this question, if it is some 2x minus 3 upon a quadratic, just take equal to y, form a quadratic equation in x. Similar question you will do, and then you can find the range. Okay. So that's all for today. Now we'll meet on Monday.